Gavin M. Roy is an industry speaker, passionate technologist, and an author of RabbitMQ In Depth. He'll offer some of his experiences working with RabbitMQ and the various clients used. Carl Hörberg is CEO of 84 Codes, known amongst other things as running the RabbitMQ SaaS offering called CloudAMQP. And Michael Klishin, principal engineer at VMware, has been involved with RabbitMQ, the core product, since 2013, and has maintained as many as 13 clients. So there's a wealth of knowledge there. So, welcome, gentlemen.
Thank you.
So, all of our guests have been involved with developing client libraries. Could you tell us a little bit about your experience working with those libraries, developing those libraries? And Gavin, can we start with you?
Sure. So I think I started working with developing client libraries in, I want to say it was 2009, maybe 2008. I needed an asynchronous client for Python to talk to RabbitMQ, and Pika existed, but it was, and it claimed to be async, but it was kind of stuck, had a sleep in the middle of the IO loop and wasn't very performant. And so I had the opportunity to work with the original authors, took over maintainership, and eventually rewrote the whole thing. Since then, I've been developing and maintaining a low-level library for Python called PANELISTS, which is all about the protocol aspect, the serialization, deserialization, and the marshalling of and unmarshalling of frames. So the kind of the base layer of what goes into a client library. And then on top of that, I have, I think, 2 client libraries at this point that I've developed and maintained on top of Pika, which is RabbitPy, which is a synchronous Pythonic client library, and a newer one called AIO Rabbit, which is an asynchronous RabbitMQ client library for Python 3.7 and higher that makes use of Python's now built-in async stack.
Fantastic. And Carl, do you want to talk about some of your experiences?
So the first client library I wrote from the ground up was the one for Crystal. Crystal is a kind of newish programming language that has like a Ruby syntax, but is using LLVM background, and it's very, very fast and it's very nice to use. So we use it a lot in our backend infrastructure. So the MQP client for Crystal was the first one I built from the ground up with everything with serialization of frames and The second one was a new JavaScript client, because the current one is not so very well maintained. The current MQP lib. So I wrote a new one called mqpclient.js. The thing, it's also way more performant. It matches the protocol better than the current standardized one, and it also supports WebSockets. And the last one that we've developed most recently is a new client for Ruby. We'll see. It's open source and open, but it's not in much use yet. It's still very actively developed, but it's a much simpler and much more performant version of Bunny, basically. So those 3 are the ones I'm maintaining currently.
Great stuff. And in terms of what are when developing these libraries, what are the sort of the key important things that are important to a developer for these libraries? What's been your experience in that, Carl?
The easiest way, I think, is to just match the protocol as much as possible. Quite a lot of client libraries doesn't do that. They invent their own kind of layer on top of MQP. And that's okay if that layer actually adds something, makes things simpler, or has a lot of built-in functionality that actually helps the user. But I found that many times in older client libraries, it's not. Like you name things weirdly that doesn't match up with what the protocol actually names things. So all the client libraries I'm maintaining are matching the client the protocol very much. But I think for users, maybe it is important to actually add more stuff on top of that, like reconnect and all that. But those things also have to work flawlessly. If they're half-baked, it's better to go without them, I think.
Gavin, your thoughts?
I was going to say, I agree. I'd say over the course of what I'll call my evolution in both writing and working with client libraries, I started out as a purist, right? The protocol is very specific. It's an RPC protocol with methods that you're going to call, and you're going to get responses back. And the user should understand that, and they should be able to implement their applications using that base stuff. And as time has passed, and I've worked closely with users, both within my organization and users of my open source client libraries, I've come to at least a certain level of understanding that in many cases, developers don't care about that stuff. They just want to publish a message. They just want to consume a message. They care about velocity. They care about robustness. What happens when a connection is disconnected, severed because of networking issues or RabbitMQ issues? Does it reconnect? Does it reconnect easily? Does it impact the work that their application is trying to do as far as complexity and whatnot? And also, I feel like at this point, some aspects of the protocol, because they're harder to understand the intent of, make it difficult for developers as well. So in my opinion, channels within RabbitMQ clients are one of the most abused aspects of client libraries. Oftentimes, I think that developers think of them as mini connections, as it were, and they spawn many of them within their application, and not really seeing that takes overhead on the RabbitMQ side. And really, they're more of a coordination mechanism. They're a way for RabbitMQ to say, hey, the command that you just sent me is invalid in some way, so I'm going to send an exception back to you. So for example, in the AIO Rabbit library that I have out, there is no concept of a channel exposed to the user. It's all handled underneath the covers. And the goal in that library is to do exactly what Carl was saying, make sure that we're covering the protocol exactly as it is stated within the library, but have a layer on top of it that makes it easier for the developer to get to the things that they want to do.
Thank you, Gavin. So you mentioned about the users' expectations. Have you seen users use client libraries in unexpected ways, in ways that changed the whole idea of the actual usage of the library? What have you seen in
oh gosh, yes. I mean, Michael could probably speak to this better than I can, because he covers and has supported a lot of users across a lot of different platforms. But for me, the most noticeable one, or notable one, I should say, within the Python community is the use/abuse of threads within Python applications and the impact of how they use threads in the library itself. And because they think, well, I'm going to create a channel, I'm going to create a connection, and then I'm going to spawn a channel per connection, or I'm sorry, per thread, they end up in a state where they're getting protocol level mismatch in the sequence by which method frames and responses from RabbitMQ are coming back in a way that Pika at least doesn't understand, because handling threading within a single connection of a client library is extremely difficult and would require synchronization at the both the connection and the channel level with the calling thread, and then maintaining a stack to understand that what was intended in again at the protocol level and how it's talking to RabbitMQ isn't chopped up in the sequence by which the Python interpreter spares cycles to threads as they're executing. Because in the end, the Python global interpreter has a global interpreter lock, and it's actually only executing one thing at any given time.
Actually, that's exactly one of the things that I've fixed in the client libraries I'm maintaining, and I've seen some clients does not support that frames can belonging to different channels can collide. But it comes with a performance penalty, because then, of course, each channel needs its own thread to handle its frames that it should handle and all that. But other things that we've seen abused, and I mean, there are so many things from not thinking through your layout of, or like architecture of exchanges and bindings. So you end up with hundreds of thousands of them, while you might have been able to use a topic exchange. Users that creates a new channel for each publish just to avoid threading problems, but then don't understand why is it so slow. Users that even create new connections for each publish, which is very, very latency sensitive. So your throughput will be awful if you try to do that. There's a lot of things people can do wrong, obviously. But
the things that I was going to say, speaking on that, one of the patterns that I've saw, and this is purely highly opinionated stuff, but a common pattern that I see that I disagree with is when users write their applications to publish, for example, and they declare their exchanges and their queues and their bindings for either publishers and consumers as part of that core application flow, which makes them really difficult to move. It makes cluster migrations difficult, or topology changes difficult. Do you guys see that a lot within the cloud offering?
Yeah, but we actually recommend it.
Okay.
We do recommend that way because some of the errors we see when people do not do that is when they're changing cluster or use transient queues or something, but expect that queue to exist, and then they get a precondition error. So yeah, we typically recommend that they declare the queue before they try to consume from it. It works fine if you, and because the other, I mean, you when you consume it from a queue, you have to know the name of the queue. So why not just declare it right before? If you were setting up queues and exchanges manually or in some other part, then you have spread out, I think, like setting up the queues and actually consuming from them in 2 different places. You're going to change a name or something, you have to do it in 2 different places. So we typically recommend users to declare their exchanges or queues before they actually use it. One problem with that, though, is that if you move to a new cluster and you start publishing messages, but you haven't started consuming yet, so the queues are not declared yet. But that means that all the messages are being dropped. They're published to the cluster, but they're not received into a queue. Of course, you always have the option, if you're moving the cluster, to export and import the definitions from the old cluster to the new cluster.
Right. And what I advocate in that scenario is taking a DevOps, quote unquote, approach where you're using configuration management and mapping all that stuff up. And where I've run into issues specifically is overly opinionated software that, going back to your original point, what made me think of this was they're declaring direct exchanges and they're not making, not making use of, for example, the topic exchange and more advanced routing features. And as we were trying to evolve or grow the usage of our messages, it became a lot more difficult in trying to change our topology when some of these old applications would pop up and be super opinionated about what they wanted, but didn't match the rest of the ecosystem.
Does that mean that the client has to be more opinionated and more restrictive to protect against some of those patterns?
No. Carl says yes, Gavin says no.
So I'd like to throw this out to the audience. Do we have any questions in terms of clients and client usages? I can see Gabriele is in the audience, and I know he's done a couple of clients. Gabriele, do you have any thoughts on developing against RabbitMQ, what you've seen?
So I think that a client must provide a low-level interface for who wants to play with it, and maybe another layer for the developers that don't want to do anything. So maybe speaking about Python, I read more than one time the problem about the threads. So it's easy to solve, but the user usually do some, let's say, they don't use Python in the right way. So maybe provide a high-level interface to hide everything, just publish messages, consume messages, and that's it. And another layer for the people that wants to go more in detail. Maybe that could be Astronaut. About the Go client that I'm writing for the streaming, I'm doing more or less the 2 layers. The first one that is the low level, and the second one is for the developers that I don't want to do anything. I don't want problem, just use the second one. So that's my opinion. I don't know.
Thank you, Gabriele. Michael, I've been told you're in the audience.
Hello, everyone. Yeah, I have been around the entire time, actually.
Oh, there you go. So, Michael, do you want to sort of give some of your experiences? You've been, working with clients since 2013. It's probably a wealth of experiences for the number of clients you've been maintaining. What's been your experience?
Yeah, so I have developed a few of them from scratch, and then, adapted or adopted or both some other clients. And I actually see that many issues are present with almost all of them, with very few exceptions like Go and Erlang. People run into the same kind of questions. I think we as an industry have a very heavy bias towards, everything works the way HTTP does. And if you take a close look at every data store, every messaging technology, every protocol developed in the last decade, usually doesn't work the way HTTP does. So you need to understand a little bit of what's under the cover. They use long-lived connections, things like that. And yeah, you can usually see very similar, either mistakes or questions, regardless of what client is involved. I honestly think Carl and Gavin have covered most of what I have to say. So my personal approach is start with a client that represents a protocol. If you want to build something on top of that, you always can do that. Maybe it should be a separate library. Yeah, this way someone who does understand how the protocol works has more flexibility. But if you want something that almost looks like HTTP, you can also wrap many things. Many abstraction layers and get something like that. But my personal experience is, as your system grows, you will inevitably have to learn a little bit about what does the protocol offer, or how do things work. Yeah, most messaging protocol abstractions, they leak at some point.
So we had a lot of announcements yesterday on the new protocol for streams. Can you give us some insight on developing clients against that? Would there be some? Will it be? What do developers need to be mindful with working with this new streams protocol?
It's a new protocol, and we already have seen questions about, when will this .NET client support streams? Well, the answer is it will not support streams. There will be a separate client developed. And if you want to combine those two in your application, you can. And if you only want to use streams, okay, there will be less code involved, right? Because streams and queues and all the queue types we have, they offer different feature sets. I'm actually not convinced that you should try to provide a unified API or have a single client that supports everything. In my opinion, you will end up with a mess. Yeah, so we expect that there will be a new set of clients developed. If you think about it, this is how it already works. We have Stomp users who use Stomp clients. We have MQTT users who use MQTT clients that we don't even maintain or honestly contribute to. It's a separate ecosystem. There are WebSocket clients that usually use Stomp or MQTT, but it can be anything else. And so there will be streams as well. And as streams evolve, those clients will become more powerful, but they will not be mixed with the clients we have. So yeah, we have one client which is fairly advanced, which is the Java client. We have Go, which is getting there, and we welcome the community to, begin working on a stream protocol client for your favorite programming language. There are good news. It's a smaller protocol. It's a more focused protocol. We can, because we, in a way, fully control it, and it's not over a decade old, we can break it in ways where it makes sense. Like, for example, someone has suggested that, the connection negotiation feature has pretty much been borrowed from MQP 091. It can probably use, 2 or 3 operations, not 5. I don't know if it would make a big difference for most applications, but we have the luxury in this particular case. We can change it, and we cannot realistically change MQP 091, MQP 1.0, or MQTT, let's say. They have been around for ages. They sometimes have their own orgs. So yeah, it's just politically or technically not realistic to do things like that. So I would say just start looking at it. And if you have questions, there will be some docs, so you can just read the code of increasingly more and more clients. I think Gabriele had something to say yesterday about this. I'm not involved with these clients. So Gabriele, can you help me out a little bit?
So yeah, let me say that the protocol itself is very easy. We have just a few commands, important commands, and let's say that the more complex part is to write something smart around to look up the leader and stuff like that, but nothing so complex. We are preparing a document to help people to write clients. We are almost there, so I think that we are going to publish the document. Just a few, let's say, best practice to avoid the same error that I did while I was writing the Go client, so to avoid the same mistake. So yes, the client itself, it's not so complex. So before, what I can suggest, before start writing the client, just wait the document, and after that, let us know how we can help. That's it.
Good stuff. Thank you, Gabriele. I've got some questions from the group. Adam Casey, are you there? Unmute yourself if you can, otherwise I'll read your question out. I've got a question here. Some AWeber clients make it very easy to skip over required subtleties around heartbeats and reliable message delivery. Can we do better? Do you want to have a go at that question, Gavin?
I mean, I think we can obviously do better. One of the interesting things in my view on heartbeats is it conceptually, to a certain degree, should be redundant to TCP, right? I mean, in the end, with TCP Keep Alive and the TCP protocol, heartbeats really more are about, you know, is my client, realistically, is my client doing what it's supposed to do? And that's where we run into issues, frankly, on the Python side. Oftentimes, people are, because they don't understand heartbeats, they starve the client from its ability to react to requests from the server. And that's something that I think that the average developer, and definitely the new developer to Rabbit, doesn't understand, is that AMQP is a bidirectional RPC protocol, and that heartbeat is the server saying, hey, are you there? Are you still alive? Over the course of Pika, we experimented with multiple different ways to handle heartbeat checking. And in the end, for my own use, in my organization, we tend to turn heartbeats off because they end up being more trouble than they're worth.
Yeah, I can only agree regarding Keep Alive or heartbeats is that, yeah, we typically recommend disable it and rely on TCP Keep Alives. There's only a single case where we know TCP Keep Alive doesn't do its job, and that's when you have RabbitMQ behind Nginx proxy. Nginx doesn't recognize the TCP Keep Alive packages as traffic, so it will close idle connection. But for all other cases that we've ever seen, TCP Keep Alive does a much better job at actually detecting missing or a broken TCP connection. Heartbeats causes so many, because it's not always implemented in the right way. It creates a lot of false positives. So if the clients or the users machine is overloaded, low on RAM or something, it can easily cause a heartbeat timeout. In the middle, when it's actually processing a very important message that is then consuming a lot of CPU, So, and the user have tuned, or the client library author has set a very low default of 5-10 seconds. And for some reason the client or the user's machine can't respond in those 5 seconds, or even half that. It has to respond within 2.5 seconds then, which can easily happen on an overloaded machine. So yeah, it's poorly implemented in many clients, I think, and it's absolutely redundant to TCP keep alive, just as Gavin said.
I'll put my distributed system developer hat on. So believe it or not, but keep alives is still the best way to determine availability of your peer. We as a species haven't developed a better way. I know it sounds weird, but TCP itself uses a very similar mechanism, and I would be happy to, rely on TCP keep alives everywhere, but there is a couple of problems with them. One is they are not necessarily enabled in every environment. In order to enable them, you have to tune your kernel. So speaking of good defaults and what developers don't necessarily understand, who would be up to tuning their kernel so that their app can run well? Most people are not prepared to do that, right? So
you can configure it. I have to interrupt there. You can configure it per socket. So in each application, so in each client library, you can tune it to a lower setting, to a more sane default. Because I agree, the default one of 2 hours is from the 80s or something. It's not a good default. But you can easily tune it to 60 seconds or whatever. And it has a much better way of, you can set intervals and period, how many TCP ACK packages should be sent, and not just, oh, I didn't get one in half the time, then I'm dropping the connection. So
I agree.
You do not have to configure any kernel settings or system defaults at all.
Well, as far as hosting RabbitMQ, it is sometimes, you cannot expect that every single client and app will do the right thing. But yeah, I was going to explain why do we need heartbeats. So in some ways, heartbeats actually undo something what TCP does, which is redeliveries. So the goal in MQP 091 was to determine when your peer is actually not available. And it's a deeply philosophical debate, but the peer which is so overloaded that it cannot handle heartbeats, it might as well be unavailable for some operations. So these days we have, for example, in our Raft library, we use a probabilistic failure detector library, which, algorithm. It has been around for over a decade. You can go to the RA website on GitHub and find the paper link. But even then, honestly, it's not that different. It's slightly more precise than just heartbeats. And it produces less traffic, which may or may not matter for your client. So I don't think heartbeats can be so easily replaced, and TCP keep alives it's a great option. We document it, right? If you have reasons to use it, I'm not gonna argue with that. But heartbeats play a role. Another role, interestingly, that they play is keeping connections around when proxies are used. Again, we have a doc section about that. Some proxies may see that,
Yeah, for sure. One of the issues, though, becomes, again, it's developer understanding, right? Like one of the longer term issues that we've had with Pika is, what do you do when you have a publishing only application in a tight loop? and they don't allow the stack to receive from the inbound socket. The heartbeat never gets processed, right? If you just,
Gavin, I think we're running into various limitations of runtimes in programming languages and concurrency models. I can name 2 clients where I think heartbeats are done well, reasonably well. So one is Java and another is Erlang, and they share one common thing. The thing being, your heartbeats are both checked and sent in a separate thread or process. So It's actually not exactly trivial to overload. You don't necessarily see them. The only effect you do see is a shutdown sequence or exception, if you will, when the peer is not available. And how do you react to that is an application architecture kind of question. I understand that it's not entirely trivial. In Python, Ruby, and so on, it may be relatively difficult to produce a client that does this. I think Go is another one which implements heartbeats sort of concurrently. So if every client did what Java and Erlang do, and Dotnet as well, it would be, the complexity would come down to is like, how do you react? Your connection can be used in multiple parts of your system. They are usually not aware of each other in a large enough application, at least. So this is why I personally think that sometimes it makes sense to use multiple connections for applications so that they are isolated in a way. They react to connection failure however they see fit without interfering with other components, with other parts of your system. So this is my best recommendation, just, better defaults. Oh, and as a RabbitMQ core developer, I can tell you that there is no such thing as good defaults. Some defaults are slightly better than others, but they all suck for someone. So yeah, if you think that the default should be, say, 30 seconds for heartbeats, okay, we can easily do that in every client, but I'm not convinced that we can easily make heartbeats a concurrent feature to everything that your application does in, say, Python or Ruby. And I don't mean this as a criticism to Python or Ruby. So it's just how their concurrency models work. They were not designed for the concurrent world, for better or worse.
Right. Well, I mean, that's one of the reasons why I'm a huge fan of async work in Python and Python 3.7 greater with, the native built-in async IO as part of the language with await and async def allows for the client library to actually handle that concurrency internally without ever being exposed to the user, which is pretty cool. But comes across as less and less Pythonic. Yeah, regarding the Erlang client, for sure. I mean, I'm an unabashed Erlang fanboy. I wish I could use it more in my day-to-day job, because it handles things like this well.
Yeah, but what I know, I think if someone wants to improve client libraries, well, you probably use a few, right? You can, like today, after this session, you can take a look at what defaults it uses. In the docs, we recommend values that are no lower than 5 seconds, but honestly, I cannot recommend like a minute or two, because if your peer is down for a couple of minutes and you don't notice, it's not great. A lot of people are looking for a much quicker detection. So I don't know, let's say we can set it to 10 or 15 seconds. And then per Carl's recommendation, see if it would be easy enough to enable TCP keep alives at the socket level. And yeah, I think that would be one step forward. But again, we are kind of facing pretty fundamental distributed system questions, and they tend to be somewhat philosophical, like how quickly do you want your peer unavailability to be detected? I'm afraid, as a RabbitMQ core team member, I don't think I have an answer.
So I've got a couple of questions from the audience. Will Hoy, are you in the audience? Do you want to ask your question?
Hey, yeah. I was just going to ask what you think is the most exemplary Rabbit client is. I guess this is going to be very opinionated. But yeah, we heard full pieces of that from Michael just then.
So the RabbitMQ core team considers the Java client to be a reference implementation. But like I said, I by no means suggest that it is, in air quotes, the best client. It's just how the RabbitMQ team kind of observes things and what we expect and what kind of tests we want to have. I'm not a Python expert, but I help out with Pika a little bit. I find it to be a very nice client that, as far as I know, is not missing anything. Bunny has, I mean, it's a good example. Some people disagree with the API maybe, but I know for sure that this is something that works reasonably well for Ruby developers.
And I jump in on the Pika thing. So
Sure.
I consider one of the fundamental flaws of what I tried to do in Pika was trying to be all things to all people. So the idea behind the way that it was created was that there was a core client library with adaptable connectors or connections. So you could use it with the blocking connection or an async connection, twisted, or any other different methodology. And I think in the end, that's one of its core flaws. It makes it really hard to be a really good blocking client library or a really good async client library because it's trying to be all things to all people.
Okay, we've got another question. Lajos, are you in the audience?
Yep, I'm here. So basically my question is that what are your opinions about the automatic recovery of connections or channels or queues, consumers and things like that? Because yeah, so basically that's it.
Can I start? So I'm the person who, as far as I know, developed automatic connection recovery as a feature like first in this community. It was maybe 2008, 2009. And then several Ruby client libraries adopted it. And then when I joined VMware /Pivotal, I was very quickly asked to add it to Java and .NET clients. So in my opinion, it's an essential feature, but it cannot cover 100%. Like it doesn't matter how smart you are. There are certain scenarios where the library cannot know what your intent is and what's the right thing to do. So for that reason, I'm fairly sympathetic to projects such as, I think, Pika and Go Client. They do not even try to provide automatic connection recovery. They provide examples and then kind of you do it yourself. That said, I think it works quite well for like the proverbial 80%. And if you combine it with publisher confirms, which is another area of improvement for many clients, making that trivial to use, at least in some common cases. Yeah, it works reasonably well for a lot of people, and you don't really have to do anything. I think it's worth having if you have to develop a new client. For example, our team works on several clients, well, not just for streams, but some of our internal features. They either have or will have automatic connection recovery.
Okay. A question from Gabor.
I have a much simpler question than the others. I'm wondering why the channel object is called a model in the .NET library. Does anybody know the answer?
Yeah, I do. So the IMQP 091 spec has a difficult history. And at some point around 2006, the set of abstractions that we know today, what we call topologies, right? Like your queues, exchanges, and bindings, they were called the AMQP model. IMQP 1.0, which, as all of you know, is a completely separate protocol, was not in the cards back then. And everyone was on the design committee was referring to it just as to the AMQP model. And so at least one client, the .NET one, just adopted that name as is.
Thank you. We have a question from Matt Davey.
Hi, can you hear me?
Yeah, go ahead, Matt.
Yeah, I was wondering if there's a mailing list to a Slack channel or someplace else that people can go if they're interested in developing a client library or learning more about the protocol.
Yeah, there is a general, sorry, there is a general core and plugin development channel in the community Slack. I think it would be appropriate to use it. It's not very active, so I mean, I think it would be a good starting point.
100%.
We can also, I mean, if it gets busy enough, we can always, you know, create a new channel. Right now, yeah, it's mostly people who want to reach out to the core team directly.
Okay, we have another question. Thank you, Matt, for that question. Johan.
Yeah, two-part question. Should we standardize the things that are already in there in publisher confirms and such and call it AMQP 092? And should we add stuff like quick connection setup? Right now there's 7 packets to set up. We could on the client and the server side make it so you set it up in much less. Could add new features to the protocol.
I think there is some, I don't know if it copyright's the right word, but there's some license related issue with using AMQP specifically. But I believe the license would be permissive of forking, and I would be a huge fan of taking 091 as it exists. There was an attempt to create a 010, which got dropped in favor of moving forward with AMQP 1.0, which obviously is a different protocol. Yeah, I could get behind that. I'd love to see further development of 091 because I think that there's a really good opportunity to iron out the warts of what exists there and build on some already really strong foundations.
Yeah, I can only agree. And there's a mechanism in RabbitMQ for detecting features that clients have already. So it could still be completely backward compatible as far as I see it.
Should be.
Should be.
Yeah, I would say we have to keep in mind that VMware is a fairly large publicly traded company. So we would be very interested in not getting into any legal disputes. I don't know if we can just rename the protocol to 092, but we can potentially start calling it because RabbitMQ at this point is by far the biggest user of this. We can begin referring to it as, I don't know, the RabbitMQ protocol. There are some political ramifications to doing this, which I will not get into, but we can do it. And as you know, we have been adding extensions to it, which is easy to do with our code gen for years. So yeah, we can absolutely do things in a reasonably backwards compatible way. And when it comes to slimming down the connection handshake, sounds like a reasonably good idea to me. I think PHP is the only ecosystem where it would make a big difference, but fair enough. What we can do I have a specific proposal in mind. So when the client connects, it receives a frame from RabbitMQ right after it sends a header. So it can send back a new frame, which combines everything you have in the open, tune, and maybe even authentication steps. It will be a new frame. It will carry a lot of stuff, but it's like one round trip instead of 3. That technically, that will be very easy to do. Now, obviously, such clients that support this feature would only be able to connect to the newest RabbitMQ versions that support it. So that's the only limitation. So yeah, we can evolve the protocol.
Good opportunity there to improve the authentication flow as well. You know, just as far as it's fairly opaque, even with the extension that that Rabbit added with regard to authentication failure. I think that there's opportunity to improve that.
Yeah, so I think what you're referring to, Gavin, is according to the spec. According to the spec, you have to close your TCP connection in some cases. To be honest, I think we already kind of solved that by introducing an extension that if a client says, hey, support this, and these days most clients do, we produce a sensible exception because we know it wasn't an abrupt TCP connection closure, right? It was an authentication. So I'm not sure how much there is to do in that area. Also, if we begin doing like more in that area, this is where I think we can break compatibility easily.
Fair enough.
I would be more interested in dropping some frames from the protocol that are very rarely used. In fact, sometimes have been deprecated for a long time. So yeah, we can drop some things, we can add new frames. We just have to be careful because we know for a fact that there are apps that use client libraries from like 2012 and they will never be upgraded.